sort of product design. We've got various different products that sit inside them, different sort of verticals. So with me, I'm heavily sit inside BIM. We very much used to sit at the very start. So as soon as someone bought a site, we'd go in and survey the actual site. Now throughout the entire construction phase, you will be scanning cross-reference against CAD models and various other bits. You've got the manufacturing side, who are heavily based in sort of aerospace and automotive. Say the crime scene side of stuff. This is really interesting stuff that we can measure like crash sites. So if a car hits a tree, you can tell you the speed the car was doing when it hit the tree, bullet trajectory, all sorts. But yeah, quite clever. Design values. This is the product design arms. So this will allow you to scan a product and turn it into a solid component which you could then create cutting paths and tooling for. So if you've got an existing product that's no longer being manufactured, you can actually reproduce that one. This is sort of the different products that you sell. So you've got the product design arms, which are these laser trackers. These are typically used for putting wings on aircraft, carry a very high level of accuracy over long distance. Got the laser scanner, which is at the front there, which is what I'm going to talk about. Got the laser projector, which will project a cutting pattern onto a surface for like drilling and stuff like that. Got a handheld scanner, which links in with a large scale scan. You've got the 3D imager as well. So does everyone know what a point cloud is? That's weird talking to that. Does everyone know what a point cloud file is? So basically, a laser scan sends off a laser in multiple beams and takes a series of measurements. Each point it takes will give it an XYZ coordinate, and then it will do that for 180 degrees, capturing both sides. It will then spin again and capture 84 pictures, and then overlays that over the top of the point cloud. Just to give you an idea, that scan will take up to 1 million points per second. So it's capturing loads of these XYZ coordinates and giving it loads of different points, which creates what looks like a full 3D image. So 2013, that's the kind of model you were getting. There's a sort of point cloud. Looks a little bit like a snowstorm. Nobody knows how to work with it. Yeah, pretty terrible. Whereas now you get this. This is just a point cloud file. There's no sort of rendering or anything been done on it. Believe it or not, this is one of our application engineers. It's at the end of his street in Spain. Ridiculous. I've got a little park at the end of my street. So this is only 15 scans all joined together. But they're really cool. So the actual laser scan that we've got is accurate to plus or minus 1 mil at 10 metres. It will travel 350 metres in each direction, so it captures sort of a full 360. The lightest scanner on the market at 4.2 kilograms, which doesn't sound like a lot, but actually when you're carrying it around on the tube, every kilogram matters. But the measuring speed, like I say, it'll go anywhere from 122,000 points per second up to just under 1 million. It has 4 sensors that are built into the actual scanner. So it's got GPS, so it knows whereabouts it is in the world, compass, so it knows which way it's pointing. It's got a height sensor, which is basically like an electronic barometer, so it clusters scans as it moves up floor levels, which just makes processing in the software a lot easier. And it's got a dual axis compensator, which once again, that saves you about half an hour per scan, because you just drop it down, hit go, and it will self-level itself to 5 arc seconds. So compared to our competitors, this is massive in sort of our world. The newer scanners also have sort of on-site registration as well now, which basically means as you move it from different positions, they self-stitch together. Which once again, this is like saving 5 days in the office trying to piece together. Because what you find is if someone's scanning on site, each position they move to, as it gets later and later on the day and they get lazier and lazier, they jump bigger spaces, and then the model trying to get it together at the end is next to impossible. So having it doing it as you move along, you know whether it's gone together or not. They all come with HDR. So before, if you were scanning outside, you've got quite a lot of bleach in the photographs. Once again, the picture still looks pretty pretty on there, but I've scanned construction sites where you've got light beaming in from the sides, you just can't see anything. So having HDR, it takes multiple exposures and actually gives you sort of clearer detail. So this is the little bit about drones. So you can actually mount a scanner to a drone. So personally I want to put 50 grams worth of kit onto a drone and fly it, but you can do it, and there's a few different companies that do it. And effectively what you've got is the scanner spinning on the same axis rather than spinning round. And then it's got an IMU, which is what sits in the centre, so that calculates the tilt and roll of the scanner to help unravel the data afterwards. And these are all sort of mainly fully automated drones as well, so you just tell it the flight path and it'll go, and that's the kind of data you'll get at the back end. So if you were surveying a building from above, this is what you'd use. You've also got stuff that will obstruct cars. You just drive at 40 miles an hour and you come back into our city. I did rugby in about half an hour. So that's quite cool. But yeah, so you can do various different sort of methods. I won't show you this. This is basically the on-site registration side bit, but it just self-stitches together. It's not going to mean a great deal to you. So we've also got the cloud stuff. So we've got quite a few sort of customers in similar spaces to yourselves. They've basically gone out and surveyed a whole series of their stores and then mapped them onto the cloud, which I'll show you that. We've got keep on the same channel. Actually, yeah, sorry. It's alright, I'm talking about HDMI still. So basically what you can do is upload all the different scans from all the different locations. For the clients we've got, they just have sort of one area and it shows all the different locations they've got all on one map. And then what you can effectively do is click on that and view everything that's on that side. I know that one is not particularly brilliant. I can do a great scanning, so I'll show you this one. So what you do then, say if you scan a store for instance, that store will appear on here. You can then just go in and view it. And this is a point cloud scan. But what you can do inside here is take full measurements. It will also snap to an axis and give you the true horizontal and all that inside there. And you can just navigate your way through just by clicking on these. What you can also do inside the cloud is create snagging lists inside here. So there is conveniently a mattress over there. So you could just click on that. Tell it to get rid of it. Well, it's not like it, but yeah, you could basically just say remove. But this was quite a cool site. They turned it into a skate park, so they wanted to keep all the graffiti and stuff. But you could also switch it into a 3D view, and you can zoom out a bit. This is all based in the cloud, and everyone just has a login. So you just type in the URL, anyone can view it, anyone can see it. So if you're in the middle of a construction project throughout the whole construction phase, you can keep creating live links inside to the master model, and everyone can actually see what's happening on site at that time, just using the scan data. It's a little bit more interesting than looking at the petrol station. You've also got a local-based version as well, so you could just send this on a USB stick. So we've got quite a few sort of military customers that can't have anything in the cloud, so they'd use this. It's just limited on your options. So we've got a few different apps that sit inside our software as well that allows you to create videos. I won't show you this one because you've seen it already. So yeah, Chapel San Fernando, Spain is the video from there. We've got various different stuff. I don't think this particularly sits in sort of your area, so I'll skip over it. But you can calculate beam deflection once it's been loaded and unloaded with concrete, just some scan data. Same with concrete floor flatness. Once you've done the scan, zoom into the screen, you can basically isolate the scan, delete all the stuff on the top, and then spit out a heat map of all the high and low points. So, not particularly relevant to you guys, but in the construction world, everyone's mouths drop. It's like, that's amazing. The VR side of it as well. So now we've just created a free VR viewer inside of our software. So once you've done a series of scans and stitched them together, you can click on the app, stick headset on, and actually be inside the scan. So that you can start viewing and interrogating it. You can't go any further than that, other than viewing it. That's when you go to, well, I'm sure to go through and start turning it to something else. But to actually view something on site, if you send one person there, the whole office then can actually view what that site's looking like at that time. So it's quite powerful in that respect. Okay, this is the really sort of cool stuff. So this is actually how you would work with scan data. So if someone else goes and does your scans and you get the scan data, you use stuff like this to actually start working and manipulating it. So we've got, this is our point sense tools. So this is basically taking a point cloud scan, which is this, inside of Revit, use the tool, the point sense ribbon, and select pipe. And then what it does is actually looks at the diameter of the pipe, searches your Revit library for a pipe that best matches that in scan data, and converts it into CAD geometry. So this will do it for all kinds of pipes, fittings, flanges, all that sort of stuff. It'll do automatically for you. It'll do the same thing with slack steel. It'll do the same thing. So search right or best library just by identifying the type. You select where you want to put the cross section through. It'll spit it out. So let's start an endpoint and turns it into actual CAD geometry. This is automatically converting the point cloud into CAD. If you've got sort of older buildings, to model this, by the way, I asked somebody, because I don't do any modelling, this would take them about 2-3 days to do this, to actually scan it, get all the accurate measurements from it, but you can actually click on this, it will identify the profile and just project a surface across it. Quite powerful. Okay, this is, so on here you've got Revit, and then you've got scan data. And then all you're doing is telling on the scan data what you're going to click on. So on this, you click in internal walls. So you click on all the internal walls. So you click on so you click on all the internal walls and it starts building it automatically in Revit. Accuracy plus and minus and nil. So it'll do it with Revit, it'll do it with doors, windows, columns, stairs, and all you're doing is just clicking on points. So yeah, really powerful sort of tool. Once you've got that, if you want to break it down even more, you can load the whole point cloud up into Revit. Create a sort of cross-section through an area you wanted to work on. On the ribbon, which you can't see very well, there's actually a door icon, which you can't see. Door. And then what you're doing is just telling it you don't know what kind of door it is, you want it to find it for you. Select the start and end point, and it will search your Revit library for a door that best fits that one and insert it. If there's multiple doors that match that profile, it's spitting out to select which one it is. So this is just taking all the other one you told it what you were going to click on, this one's searching for what it is. So that's inserting that, I did the same thing with doors, windows, and sort of components inside the point cloud. You've got the, I'll skip over the civil service extraction, curve extraction. This is quite sort of key though, so what this will do is if you've got scan data, because it's spinning the laser